All right. Question number 1. I created this histogram and I changed the bucket size to smaller just to where I can show all of the data, including this outlier. For number 2, created the scatter plot and I added a trend line. Also added the equation up here with the y-hat equation and the r-squared value right here. Created another scatter plot to show the relationship between percentage of bachelor's degree and the 2020 Trump vote percentage. Made sure to label the axes here. Added another trend line, and I showed the equation up here with the r-squared value, 0.453. Oh, sorry, that's the same chart. Here's the second chart. But I did the same thing, made a trend line. Made sure to label the x and y axes, and then I added an equation up here with the r-squared value. And then between these two charts, the second chart shows the stronger correlation with the data because it has a higher r-squared value at 0.548 instead of, which is higher than the second one at 0.453. Now, question number 5. I used the Excel Miner tool pack to create a correlation matrix, and then after looking at the data, I saw that the strongest correlation is between the 2020 Trump vote percentage and the bachelor's or higher percentage, and it's the highest because it has the highest absolute value at 0.74, and then the lowest absolute value here at 0.038 shows that the lowest correlation is between unemployment percentage and the 2020 Trump voters. Question 6. Use the Excel Miner tool pack to create a linear regression model. This is my second trial of the model. The first one, I took out population because its p-value was greater than 0.05. And then I got the y-hat equation here, 90.3545 plus negative 0.1848 x1 plus negative 1.0063 x2 plus negative 1.7238 x3 plus 0.3515 x4. The variance, to answer question number 8, the 2020 Trump vote percentage variance is explained by looking at the r-square value of the model, which is 0.7203 or 72.03%. For 9 and 10, I created a line plot to illustrate the time series of monthly supply of housing in the United States. Made sure to label the axes. And then I combined questions 9 and 10 into this graph right here because I used a trend line to show the equation, put the equation right here, and then the r-square value, which is 0.578. Then for question 11, used the same line plot but made a third degree polynomial trend line by just going to the series, chart series, and then changing the trend line type to polynomial instead of linear. And I changed it to a third degree polynomial line, and I also added the equation and the r-squared value right here, which is 0.651. And then for questions 12 through 14, right here on the 6's sheet, I added a column which counted the number of times a 6 was rolled in each of the trials. I used the COUNTIF function just to count the number of times a 6 was rolled from each roll. In this column, and those values are anywhere from 0 to 3. And then To find the number of times at least one six was rolled, I used the count if function to count the number of times at least one six was rolled in this entire trial, which was 436 or around there. It'll vary. And then to find the probability of times at least one six was rolled, I took this number and then I divided it by 1,000 because that's how many times the trial was conducted. And then I just repeated that same process for the next two questions. So for the number of times two sixes are rolled, I used the count if function to count the number of times at least two sixes were rolled. And then again, divided that number by 1,000. And then for the last question, the number of times three sixes were rolled, again, used the count if function to count how many times that was, and then divided it by 1,000.